Good afternoon. My name is Forrest Bryant. I'm happy to be a part of this excellent team. We have Matthew Abai, Amina Robb, Andrew Cruz, and Shui Zhu. So our long-term goals for this project were to develop the electrical equipment for a large-scale 3D printer with an 8 cubic foot printing space. This project was presented to us by TI with our sponsors Nathan Shim and Leo Estevez. We'd like to thank them at this time for all that they've done for us and all that they will continue to do for us this upcoming semester. Our goals for this semester specifically, though, were to convert the design for a milling machine into a small-scale 3D printer to be used as a sort of prototype for the large-scale 3D printer. Now, the hardware that we were given at the beginning of the semester included a BeagleBone Black with a cape and peripherals, such as motors. Now, since the hardware and software which we were using is meant for a mill, we had to make some adjustments. So Matt, he was in charge of HAL and Linux CNC, and Amin was in charge of G-code. Now, HAL is a hardware virtualization system with Linux CNC that reads inputs and provides outputs to the actual hardware. G-code sends information to HAL to control the physical tool, and these both work in tandem to control the entire system. The hardware, Andrew, Shui, and I were in charge of the hardware portion of the project. Our job was to redesign the cape, and we did this by using Altium, and we used Altium to address the issues of pin shortages, the removal of unnecessary hardware, and the addition of hardware that will be needed for the large-scale 3D printer. So once our project is complete, TI will release our design open source so that consumers will be able to replicate the process inexpensively. And about the beginning of next month, we hope to launch a Kickstarter for our project. And anybody who's interested, I would encourage them to take a look at that. And any backing that we receive, we are very grateful for. Thank you for your time, and I'd like to open the floor to questions.
I understand it's going to be big.
Yes.
But how are you going to supply all the material to print something big? What's the printing head and the kind of speed we can expect to make something 8 feet across?
Yeah, well, we're actually working with an extruder team, and that's kind of their job is to figure out the material. I think they've come up with a type of plaster. That's what they're using right now. And it'll just be driven by a couple of motors, a couple of big stepper motors. Any other questions?
So you're not really building, you're just building a full-scale model?
Well, for this semester, we were just supposed to kind of convert what we were given from a milling machine to a small-scale 3D printer and use that to kind of understand how the electrical equipment for a 3D printer works. And then next semester, we're going to start scaling up. We've already kind of begun the process by redesigning this.
So you're going to build the 8 cubic foot machine?
Yeah, we're not in charge of the actual structure. We're working with 2 other teams, actually. The extruder team and a gantry team. The gantry team's going to actually build the structure. We're just going to build all the, or not build, but develop all the electrical equipment for it. So the motors, motor drivers, the BeagleBone hooked up to the cape, and power supplies and stuff like that. Fans, heater beds.
And what is a cape?
A cape,
A cape is a board that sits on top of the BeagleBone. So Raspberry Pi and BeagleBone both use the system where you can extend the hardware outputs. And a cape is essentially just another PCB that sits on top of the BeagleBone and attaches itself directly to it, using the GPIO pins for input and output.
And so functionally you're using it for what?
So essentially, the BeagleBone will control the actual hardware, will make sure the circuits are lined up correctly. Or not the BeagleBone, the cape will do control the hardware, but the BeagleBone will do the processing and the thinking of the structure. So it will send outputs to the cape, and the cape will ensure that the output, we don't break voltage measurements, and we send it to the correct locations along the actual board itself. It also will help us control more structures than the amount of pins we have by giving us shift registers and other stuff such as that.
Is it a cape processor?
Eventually, you can see the cape is right up there, the very top right. It has multiple processing units on it, but it does not have like a CPU